This is part 3 of the complete one-way ANOVA, looking at the relationship between time and attention. In the second video, we made it through all of the calculations up to and including the F ratio. So we're going to start here with putting together our ANOVA summary table. So an ANOVA summary table, these are the basic 5 columns: the source, sum of squares, degrees of freedom, mean square, and F. And now we need to put together our rows. So the rows are going to be labeled in the source column. And basically the easiest way to figure out what the rows are is to go back to your sums of squares. So whatever the little labels are on your sums of squares, those are your rows. So our first sum of squares was A, our second sum of squares was S over A, and our last sum of squares was T. All right, so what do these things really refer to? You don't need to put this little label that I'm about to put on this, but I find this to be helpful. So A is our between subjects stuff, S over A is our within subject stuff, and T is our total. All right, so once you have the A, the S over A, and the T there, all you're going to do is go back to all the calculations that you did, starting with the sums of squares, and you're going to fill in those answers in this table. So our sum of squares A was 14, our sum of squares S over A was 750, and our sum of squares T was 764. Our degrees of freedom A was 1, S over A was 12, and T was 13. Our mean square A was 14, our mean square S over A was 62.5, and our F ratio was 0.22. All right, so that is the end of calculating and summarizing. So now it's time to evaluate our null hypothesis, or to evaluate, I'm going to think of an easier way to put this. We're going to evaluate our F ratio. All right, so we're going to start with our null and our alternative hypotheses. So in the one-way ANOVA, the null hypothesis is there is no treatment effect. Okay, there's other ways to say this. We can say the means are equal. We can say mu1 equals mu2, which is just a fancy way of saying the means are equal. When we move down to our alternative hypothesis, it's basically the opposite. So our alternative hypothesis says there is a treatment effect. Another way of saying it is the means are not equal. And if we do it with the mu's, it's mu1 does not equal mu2. And even though we don't quite need this at this point, let's do our research hypothesis. All right, so what do we think is the predicted outcome of this study, looking at the relationship between time and attention? I'm going to say time affects attention. All right, remember with a research hypothesis, there's really no right or wrong prediction you can make, but there is rules in terms of format. So in your research hypothesis, you have to mention your independent and your dependent variable. Okay, so those are our hypotheses. Now it's time to evaluate our F ratio. Now it's time to evaluate our F ratio. So we're going to draw our theoretical sampling distribution of F. Remember, this is F ranging from 0 to infinity. Over here we've got frequency and probability. And what we need to do now is we need to find our critical F. So how do we find our critical F? So remember, you are going to use the critical values of F table. There's one on our Blackboard site, there's one in the back of your book. And in order to find the critical F, we need 2 pieces of information. We need the degrees of freedom for the numerator and denominator of our F ratio. Well, what does that mean? let's think about how we wrote our F ratio. Our F ratio was the mean square A divided by the mean square S over A. So what is the numerator of that F ratio? Oh, this is driving me nuts. What is the numerator of the F ratio? Well, that's the top. So the numerator is A, and the denominator, or the bottom, is S over A. So what degrees of freedom do we need to look up? Well, degrees of freedom A is 1, and degrees of freedom S over A is 12. So you're going to go on your critical values table, and you're going to go over to column 1, and you're going to go down to row 12. And when you do that, the critical value of F is 4.75. So once you find the critical value of F, now you need to go back up to your ANOVA summary table, and you're going to find your observed F. All right, that's the F that we calculated. And you're going to place that on this theoretical sampling distribution. So again, this is F ranging from 0 to infinity. Here's 4.75. So where does 0.22 go? Does it go to the left or the right of 4.75? Hopefully you figured this out. It goes to the left. So 0.22, this is our observed F. So now, let's see, what color should I do this in? I guess I'll do red. All right, so our critical F is 4.75, our observed F is 0.22. What is our decision? Remember, if our observed F falls to the left, the decision is we fail to reject our null hypothesis. And what does that mean? All right, let's go back up to our null hypothesis. Our null hypothesis says there's no treatment effect. We can't reject that statement. So what that means is there is no treatment effect. We can't reject the statement, so we have to accept it. I use that word accept loosely because we never really accept a null hypothesis. But if you're trying to wrap your head around it, when we fail to reject, it means there's no treatment effect. That also means that the means are equal. And what does it mean in terms of our study? If there's no treatment effect, if the means are equal, what that means is time does not affect attention. So if I'm drawing a conclusion in real language, the conclusion is time does not affect attention. Time does not affect attention. The last thing that we're going to do here is journal format. Remember to do journal format. The first thing you're going to do is put the letter of the analysis you did. In this case, it's an F. In parentheses, we're going to put the degrees of freedom that we used to look up the critical F. In this case, it's 1, 12. Then we put an equal sign. We put our observed F after the equal sign. Our observed F, not our critical, so 0.22. Then we put a comma. And because we failed to reject, this is actually the first problem we've done where we failed to reject. Because we failed to reject, its P is greater than 0.05. So that is our first one-way ANOVA all the way through to the end of the problem.